We've discussed that we cannot find general solution to trajectory, so maybe this title isn't quite correct, but if you want to find a precise solution to a trajectory of your rocket, you're going to have to, well, integrate, let's say, calculate it numerically. Okay, so what this means is we've gone over it just very briefly before, but you're gonna have to take the equations of motion, so the six equations. Well, first you're gonna have to predict the forces. Okay, I'm just gonna outline it really quick. I'm not gonna talk about how to do all this, but it's good for you to know a bit, just to have the context. Okay, I'm gonna discuss how to properly simulate this and solve the trajectory in say section 4, which I'm going to talk about simulation. But first, you're going to have to predict the torques and the moments, get them through your equations of motion to find accelerations, and finally you can integrate and find well, how the rocket has moved. Okay, this would be the outline of what you're going to have to do. So there are different ways to do this. Okay, you don't have to solve the 6 equations. Actually, solving the 6 equations means that your rocket is free to move in the 6 possible ways. So if you recall the axis of the rocket, so imagine the rocket is here. So the rocket is free to move. So it can move in this axis, and this axis, and this axis, and it can also rotate in each of these axes. So if we solve all 6 equations, if we let the rocket move in these 6 degrees of freedom, which is what we call, well, we will have a 6 degrees of freedom simulator. All right, but we don't. This is the most general form of solving the problem. We don't have to do it this way. We could simplify the problem, and we could do a 3 degrees of freedom, which would be just a 2D rocket. Okay, so you only have 2 axes. Okay, and it can only oscillate in the normal axis to this. So it can oscillate in the z-axis, and it can move in the x and y. Okay, so it can rotate in the z-axis. So this would be 3 degrees of freedom. It does simplify quite a lot, and we could kind of decouple the 3 equations. So yeah, it simplifies, but it's not so general as the 6 degrees of freedom. All right. So if you don't want to do your own simulator, there are actually some simulators out there that you could try them out. So you probably know OpenRocket. OpenRocket is nice. I believe is. I think I read it as a 6 degrees of freedom, but honestly I haven't used it so much. But I know its aerodynamic model is pretty good, but still I don't have a feeling of I can't see what's inside, so I would go to I prefer to doing my own simulator, okay, because you can't really input something, maybe the masses in some way you'd like. You don't have full control, okay. It's a program you haven't done, but still, starting out, of course, go with things that already exist. OpenRocket is really nice. Plus, it has graphic user interface, which is great. So it's awesome. And if you want to go with something more advanced, there's an open source simulator, not so well known, which is the Cambridge. I think it's just Rocket Simulator or something. Simulator. This is great. This is 6 degrees of freedom for sure, and you can actually plot out. You can see how the trajectory the rocket has. I'm not sure you can. I've read that the calculations are in 6 degrees of freedom, but I don't think you can actually plot that in OpenRocket. In Cambridge, in the Rocket Simulator, you definitely can. Plus, it has, I haven't discussed this, but it has a parachute, a descent simulator, which is 3 degrees of freedom, if I recall correctly. And this is open source. I believe they've done it with MATLAB, so you can see everything what's inside. So it's a great simulator. Plus, it has more stuff. I think the last version they added a graphic user interface which looked like OpenRocket. I think they used the OpenRocket one. Plus, it has a parachute. I think OpenRocket doesn't have it, and it has another thing that you can add. I think you can add your own wind. So imagine you have a profile of winds. So you can add that and see what the rocket's going to do. I think in OpenRocket you can only just put, I don't know, just 3 meters per second wind in this direction. You know, in this you can, I think you can put your own wind. So yes, there are some stuff out there that you can definitely start with before hopping on and doing your own simulator. Your own simulators is, I think it's worth it if you're doing something serious, because yeah, it's your code. You can see, you can write it your way. You can see everything you're doing. You don't have to adapt into an input. I think we've used this once, and the input was terrible. We didn't like it at all. And then you can use your own models for aerodynamics. So to start with, definitely go with something that is existing. Okay, but it's good to know that the limitations of every one of these, and that maybe the best option, on the long run, is doing your own simulator, just to get that idea sinking in. Okay.